this triangle, matrix A where its determinant is equal to A, this triangle whose area is equal to W, and this complex equation, where H equals Tuah, find all values of Tuah. Starting with question 1, to find the value of H, we will use the Pythagorean theorem, namely, A squared plus B squared equals C squared. Plugging the values in yields natural log of H squared plus natural log of 2H squared equals natural log of 4H squared. Since 2H is the same thing as 2 times H, we can expand the H using some basic logarithmic properties. The same thing applies to 4H. Now we'll use the distributive property to expand the squared terms. Since there is natural log of H squared on both sides, we can subtract natural log of H squared on both sides to eliminate it. Here, I will move the terms with H to the left to make things easier to simplify. Now I'll factor out natural log of H here. Then, using the difference of squares formula, expand these two terms. Now we just simplify. We now have a quadratic equation in terms of natural log of H, where A is equal to 1, B is equal to 2 times natural log of 2, and C is equal to 3 open parentheses natural log of 2 end parentheses squared. Using the quadratic formula to solve this yields. Now let's simplify the discriminant. Adding common terms. Now take the square root of 16, then, using a property of absolute value, cancel out the square and square root of natural log of 2, and attach the absolute value function to it. Now we have two cases, addition and subtraction. If we add both terms, we get so natural log of H sub 1 equals 3 times natural log of 2. Subtracting yields. Negative natural log of 2. Solving for H, we get H sub 1 equals 8. And H sub 2 equals 1/2. Now, using the value of H we found, solve for A. First, calculate the determinant of A using the AD minus BC formula, then set it equal to lowercase a. Now calculate the two cases of A, when H is equal to 8 and when H is equal to 1/2. So our values for are 26 and -4. Now let's solve for the area of the triangle. First, write down the first 3 points of the triangle. Then, add ones to fill the right side to make a 3 by 3 matrix. This will give us a 3D parallelogram, but we only want the triangle, so scale it by 1/2. Set this equal to W, and then calculate the determinant. Now we just have to solve this complex equation. First, separate the real and complex parts. This will give us x equals 5. Now, plug that into the complex part and solve for k. so k equals 21 fourths. Finally, solve for both cases of Tuah. Our final values for Tuah are 6552 and negative 63 over 2 or negative 31.5.